Welcome to this panel discussion at North Shipping 2023. Today we are talking about rotor sales, voyage optimization, and some practical experiences on board a ship equipped with rotor sails. My name is Ville Paakkari, and I will be hosting this discussion for the next half an hour or so. But to begin with, I would like to hear more about our panelists, experts. So if you can give brief introduction of yourself, what do you do at the moment, what is your background, and so on. So everyone gets to know you a bit better.
Yes, my name is Helge Hals. I'm a captain. I've been a captain for 28 years. And the last 2 years I've been on board SE Connector with sails, and I was 6 years before on board without sails. So and now I work as a consultant.
Hello, my name is Ossi Mettälä. Thank you, Ville and Norsepower, for inviting me. I work for NAPA in NAPA Shipping Solutions as a sales manager. We do voyage optimization and performance analytics for ships, ship owners, and charterers. My background is in naval architecture, and I've been in the forefront of shipping digitalization for some time now.
I'm Jukka Kuuskoski. I'm the Chief Sales Officer of Norsepower, and the main job is to sell rotor sails to more and more satisfied customers.
Yes, hello. I'm Severi Sarsila, a sales engineer at Norsepower. A lot of involved with performance measurements and performance predictions, and lately also be working with a lot with NAPA's voyage optimization tool to further optimize the rotor cell performance.
Yeah, thanks all. And I think we have really an expert panel here today discussing these topics. So first, we are talking about rotor sails, but it might not be self-evident for everyone what is rotor sail, why does this cylinder work. So Jukka, could you give us a brief introduction? How does it work? What is a rotor sail?
Okay, the rotor sail is a mechanical sail which produces a thrust force in favorable wind conditions. And how it does that is with the help of a Magnus effect, which happens when the rotor is spinning with the help of an electric motor and wind meets the spinning surface. So as wind comes from the beam, which is the optimal direction of wind, the rotor sail creates a low pressure area on this side while rotating clockwise, high pressure area on the aft side, creating a lift force supporting the ship's main propulsion, allowing lower fuel consumption and of course reducing emissions at the same time. So that's the main principle and benefit. And with learning from our customers, we have also learned of other benefits, which we will hear more of later. But this is the main reason why rotor sails are developed and help the customers save fuel, save money, and of course save the planet.
Thanks. Okay, so now Jukka is claiming that there are fuel savings, there is other savings or benefits. Helge, you're the man. You have been sailing with this equipment. Is that true? Does it really work?
Yes, there is no doubt. I was, as I said, 6 years on board the vessel without sails, and after we changed to or got the rotor sails, the vessel we are saving. We are saving a lot, and it's very difficult to say exact how much. But as I mentioned, what I calculated how the vessel was before and now, I reckon 25%, and of fuel saving.
25% of fuel saving. That's a lot.
It's really, and also with a ro-ro vessel can be quite rough in the North Sea, yeah, with rolling cargo, and you can have a lot of damages, yeah. So you sometimes had to stay at anchor or stay alongside, wait for better weather. And with the rotor sails, she's stabilizing the vessel. So we can now go in more rough weather with the vessel. We go faster. We are also keeping the route better than we did before. Yeah, we had the same route before and after. So yeah, it's only pluses. And yeah.
That's very good to hear. So you mentioned you can go into rougher weather. Is that correct? So you also have let's say journeys that you can now take which wouldn't be possible beforehand. Was that did I understood correctly?
Yes, that is correct. Because the vessel have fin stabilizers. There's no bilge keel, so you have a fin stabilizer. And then you need to have the speed to keep her stable, yeah, to not roll, yeah. And I am there has been many times I know that I had to go on anchor. I had to wait maybe a day or so for the weather to improve. And with the rotor sail, I managed to go, and of course then we have a quite high speed, yeah. With so the fin stabilizer work very fine.
Oh, that's impressive. And the ship, we have it actually now just on the background. It's I think one of the most powerful sailing ships in the world as of when you measure the sail power on installed. With this much sail power, since the focus of today's panel discussion will be voyage optimization, how can we use the knowledge of the weather to enhance the savings? How do you see this on based on your experience? Is it feasible? How can you benefit from the weather forecast?
Yeah, we really need to have a good weather forecast. That is true, and we do it mostly manually on board. Yeah, we have Actis, so we don't have any paper charts. But I have one chart which I'm using to just check how long is the extra distance if I deviate 10, 20 degree. And so on, but for sure to have a good weather optimization from or a program will be really helpful. So yeah.
Yeah. Then I guess next question goes to Ossi about the automating this process. So can you first describe what is voyage optimization from NAPA side?
Sure thing. So NAPA Voyage Optimization is a cloud-based solution providing the most optimal way of operating the ship from port to port, considering not only the weather, from wind to wave to swell and ocean currents, but also bathymetry data for the squatting effect of the vessel. But also on top of that, the most important part might be the performance model that we use from the ships. On NAPA, we build it. There are ship-specific models created using naval architectural principles, and on top of that, with Norsepower, we have been adding the Flettner rotors on top of that, the Norsepower rotor sails, so that the whole combined forces can be calculated and then optimize the route from port to port to reduce the fuel oil consumption and emissions as much as possible.
So essentially, automating what professional captains like Helge are doing on board SC Connector, would that be a good description of your service?
Exactly. So, especially combined with Norsepower, the weather routing becomes quite a challenging optimization challenge. You can think about it's not only about how the vessel itself will perform in the weather, but what kind of benefits that we can gain from the wind. So in this case, the wind is not anymore a drag, a resistance force for the ship, but rather it can produce a significant amount of thrust. And to tap into that force, you have to have right tools to get the most out of your investment, most out of the rotor cells.
Yeah. Next question I think goes to Severi about this impact Ossi mentioned. So at Norsepower we have been simulating this quite a bit with supported by NAPA, of course. So can you give us some idea of of the impact of the enhanced performance with voyage optimization combined together with rotor cells or without?
Yeah. In the typical case, we see maybe 5 to 25% fuel savings when we operate the rotor cells on the shortest route. Then, if we apply the voyage optimization, we can see even like 100% increase in the fuel savings. So if previously you had 5% fuel savings on the ship on the shortest route, then you could have 10% on the optimized route. And it really helps a lot, and there is a huge benefit to it.
Yeah, so really a powerful tool, and I guess really good match because yeah, it kind of is self-evident that wind propulsion is dependent on the weather. Um, yeah, how about onboard SC connector? What can be done with manual voyage optimization? Uh, so do you actually keep the schedule, or is it just a longer voyage?
Yeah. You know, first of all, we have measures on board or equipment to measure exactly how much fuel we are using per liter. Yeah, we are. So that is one thing, and we always aim for, of course, to be on time and use the smallest amount of fuel. But like I say, now when we don't have a good weather routing program, which is so we have to do it manually. Yeah, we are like I say, if I'm testing, I deviate 10 degrees. Okay, I do so much more distance, and then I am there, and then the wind is from that angle instead of that angle, and you are calculating manually. Yeah. But the task is you have to be on time and you use a little fuel as possible and cargo safe. Yeah. So of course with that kind of tool will be very helpful. Yeah. Because we have to check manually at the moment. Yeah. We have some kind of routing program, but it's not taking the wind into consideration. Yeah. So I don't know how much more speed I make. Yeah. This I have to calculate manually. Yeah.
So good digital tools in that will help a lot.
Yes, and of course it is also good to have that you have to put in a lot of parameters how the vessel behave, yeah, and put some limitations and like this. But I'm quite sure that will be in your program like this, and you have, like you say, you have all the data of the vessel in NAPA. Yeah.
Yeah, very good, very good. Then we could talk a little bit about some of the new developments in the market. So mainly the regulation, which is the hot topic for shipping in general. So how does this all play out with different regulations? Maybe we can start with Jukka. So yeah, what is your perspective to regulation in that?
Yes, the different requirements for energy efficiency improvement of existing and old ships and also new ships, of course, puts a lot of pressure on ship owners to make sure that their fleet that they are working with complies with the requirements. And such indexes are, of course, calculated to find out the status of the ship at the present status, and then what can be done to improve the index and fulfill requirements and go even beyond the requirements to improve the energy efficiency. So rotor seal technology is one very good and proven way of being able to comply with such ship energy efficiency design and existing ship indexes. Also, the CII, which is more related to then the real everyday operation, is an important index which many ship owners need to pay attention to, and similarly, their rotor sails can play an important role in making ships compatible and compliant with the regulations.
Yeah, Severi, can you tell us a bit more about how can we assess or predict the impact of rotor cells or rotor cells with voyage optimization on the CII especially?
Yes. So for the CII, we can convert the thrust of the rotor cells directly into the main engine equivalent power, and then then we can already see a reduction in the CII figures of the vessel. But then if we optimize the route of the vessel so that we have better wind conditions, that means more thrust from the rotor cells and even bigger main engine power savings will lead to even higher CII reduction of the vessel.
And if I may add on that, the benefit of weather routing for the CII, especially with Flettner rotors, is that the CII calculation itself is simple. Fuel consumption divided by nautical miles covered. The fuel consumption reduction is clear. You reduce fuel power on the main engine, reduce fuel consumption. But usually the routes that are optimized with Flettner rotors are also longer than the equivalent route without the Flettner rotors. So it's like a double whammy for the CII. You reduce fuel consumption, increase the sail distance while keeping the same arrival time to the port, meaning the CII is reduced from two fronts.
Yeah, so would it be correct to say that the impact on CII, you can predict it both in the long term and also in the kind of shorter term in the actual operating environment? So basically optimizing the individual voyage. Is that doable?
That is exactly what I meant. So you have to optimize your ongoing voyages, your near-time voyages, but also you can look further down the line. So what will be the end result throughout the year until end of the year, or at the time of redelivery of the vessel? What will be the CII, and then predict on that.
Very good. Helge, would that help your work or the captain's work on board to kind of be able to predict also the regulatory compliance?
Yes, yes, it will. I'm sure that that it will help. Yeah. So, and of course, when we look at all, I think for the future for the maritime industry, yeah, we really need to do something, yeah, to and everybody is waiting, and the regulations are coming. We know it will be there. So if they're gonna just reduce the speed in the end, or if there will be a lot more sales, and I believe the latter. I think there will be a lot of sales because it's really a nice source of energy. Yeah.
Okay, let's have a 1 minute from each. Little bit going to what Helge you just said about how optimistic are you about the future of wind propulsion and rotor cells, of course.
Yeah, I'm very optimistic. I have tested it. I have seen how it works. Yeah. So and I'm also optimistic of the future. Yeah. Because where we have to go the next 30 years is set. Yeah. We have to do something, and I'm sure that rotor sail, that will be really a huge, yeah, it will be really good.
Yes, and the add on what Captain just added, the regulations are coming and they are already on the source step. So I bet the industry will be divided into different camps, so to say. So there will be those who are on the forefront of everything, the shipping companies, but also companies who are providing solutions for this. And from the shipping companies' perspective, if you are proactive on this, look for the solution to improve your energy efficiency, operational efficiency, you will gain a competitive edge, maybe in form of the CII, but also, let's say, you could prevent slowdowns or slow steaming events just to keep up with the regulations. With efficient ships, you can keep up the operational speeds as is required. And then there, of course, many companies are looking for ESG values these days, and the cargo owners and consumers will or value those ship companies who look for those values.
Yes, the market has really become more active compared to a few years ago. The ship owners and also charterers are very motivated to look for solutions that will reduce fuel consumption, reduce emissions. And this is a very positive trend that I see, that both charterers and owners are talking together about how they can implement new technologies, new solutions to make it happen. Previously, it was more the ship owners who were in the focus to say, why don't you improve your ship's efficiency? But they need, in some cases, the strong support of the charterer as well to really make it happen and make it happen quick. And this trend we see very positive on the market. Also, as the alternative green fuels are more and more coming to the market, this will promote use of such energy efficiency improvements. The expensive fuels or whatever fuel is needed, there is the best solution is to save as much of it as you can. So a very positive market situation, which we are happy to work in and do our best to support our customers.
The way I would see it, that in the near future, more and more ships will install rotor sails, and also these installations will become more ambitious, so that when we can enter the new build market and the whole ship can be optimized for the wind propulsion systems, then we can see the increase in the wind power proportion of the main propulsion. So yeah, then that will lead to direct cut CO2 emission reductions of the shipping industry.
Very good. Thank you, and I wish you a good exhibition.